Welcome to Lesson 3-5. That's Topic 3, Lesson 5. Today we get to evaluate algebraic expressions. Yesterday we learned what algebraic expressions are. They have variables, an unknown. And today we're going to evaluate them, which means get the answer. And how do we do that? Let's take a look. All right, how do you evaluate? Well, say, here we go. We've got this expression 2n plus 1. That's 2 times n plus 1. Now, we can't really evaluate this now because n is unknown. We need to know what n is to be able to evaluate this. Before we go and do that, how many terms do you see there? I hope you said 2. We have 2n is one term, and 1 is another term, and they're separated by the addition sign. Do you see a coefficient? 2 is the coefficient of n. It's a number that goes with a variable. And of course we have the constant 1. 1 is constantly 1. It never is anything else. It's reliable. You can always count on it to be 1. So here we go. Let's look at this. Well, first we need a value for n. So I'm going to define n to be equal to 3. And if I wanted to evaluate this, I just need to substitute 3 in every time I see the variable n. So now I have 2 times 3 plus 1 more. And of course, our friend PEMDAS says we multiply first. So 2 times 3 is 6, plus 1 is 7. And so the solution to 2n plus 1 when n equals 3 is 7. There you go. You've evaluated your first algebraic expression. Okay, so one little vocab word there, and that is substitution. That's the act of changing the variable to a number. You substitute the number for the variable. You switch them out. So there's your vocab. All right, let's look at a real-world situation that we can model with an algebraic expression. Eric collects miniature cars. He has one large case that he holds his cars in. That thing can hold 20 cars. He also has 3 same-size, smaller cases filled with cars. How many cars in the smaller cases, you're wondering? We don't know. That's going to be a variable. And as a matter of fact, we're going to use n as the variable to represent the number of cars in each smaller case. So let's draw a bar model to kind of see what's going on here. All right, here's a bar model we have. And what we have here is, this is the bar for the large case. There's only one of them, and it has a value of 20. Down here I have the 3 smaller cases, and each case can hold n cars. So I have 3 equal groups of that, and then I have this other 20 here. And the whole thing is what I'm trying to find out. And so if I was to put this together, I would say I have 20. That's for the large case. Plus, I have 3 groups of n cars. Well, groups of, we know, is multiply. That's multiply. So we have 20 cars in the large case, plus 3 groups of n cars for the small cases put together. So this algebraic expression gives me the total cars that Eric has. Now the next part of the question asked me to calculate the actual number of cars if each smaller case holds 10 cars. And so what I'm going to do is, since n is the number of cars in each of the smaller cases, I'm going to substitute the variable n with the number 10. So I get 20 plus 3 times 10. I like to substitute in and use those parentheses to show that's the value I just put in. Order of operations. Mighty PEMDAS says you see an addition, you see a multiply, you got to multiply first. So I'm going to make that 3 times 10 is 30 plus 20. And if I add those together, I get 50 total cars in his collection. Sometimes they might ask you to evaluate the expression with different values. So in this case, they're saying instead of 10, use 12. So we'll do that. So I have my original equation, 20 plus 3n, and I'm going to substitute the value. They say n equals 12. So I'm going to make n equal to 12. 20 plus 3 times 12 Then 3 times 12 is 36 plus 20. And I get an answer of 56 cars. All right, you've seen a couple examples. Now it's time for you to try. We have the expression 50 minus t, and I want you to substitute 20 for the variable t and evaluate that expression. Get an exact answer. We'll talk about it in class. All right, let's make it a little harder. We're going to evaluate some algebraic equations this time because I have an equal sign. And we're going to be doing that with decimal numbers. So Julie's family took a 4-day trip. Julie's mother wrote an equation to calculate their gas mileage, M, in miles per gallon. So D is the number of miles, and G is the number of gallons, and so we get miles per gallon there. And so we want to do it for the entire 4-day trip. So we have some data on this table here, and the first thing we probably need to do is add up the total miles for the whole trip and the total gallons for the whole trip and see what we have. So adding up the miles, I get 1,560. Now I'll go for the gallons used. Adding that up, I get an even 60 gallons of gas. And so now I can use my equation. D is equal to 1,560 miles. And G equals 60 gallons. So substituting that into my equation, M equals D over G. D is 1,560 and G is 60. I can divide top and bottom. I can see right away by 10. So I'm going to make that 156 divided by 6, which isn't going to be too bad when I divide that out. Cool thing about a smart board is I can move some things around and give myself some good room here. Anyway, 6 does not go into 1. It goes into 15 twice. Subtract. Check. That's less than 6. Good. Bring down the 6. It goes into 36 6 times. So M, when I evaluate that, is 26 miles per gallon. And I would say if you were on highway, that's probably not very good gas mileage. Maybe they're in a big truck or something, or a big SUV. Not so good gas mileage. All right, now you try. You have the expression 3 4/10 plus 12a divided by 4 for the number a equals 10. A is going to be substituted in with the number 10. Remember to use your rules. PEMDAS. Do not anger, PEMDAS. We do parentheses, exponents. Multiply, divide are same importance. Add, subtract are same importance. These are left to right. All right, have at it. We'll talk about it later. All right, now we're going to evaluate algebraic expressions with fractions. Mr. Grant wants to tile a 27 square foot area with square tiles. S is the side length in feet of a square tile. So if I have one tile here, each side is S. It's a square, so they're the same. I have the expression 27 divided by S squared to find the number of tiles Mr. Grant needs to buy. So they gave us that formula. That was nice of them. 27 divided by S squared. Now, S, they already told me, is 1/3. So I get 27. I'm going to substitute S in with 1/3. 1/3. And that's squared. And as we might recall, that is, we do exponents first, right? PEMDAS. Okay, we do exponents before we divide or multiply. So I'm going to have this to do next. And that's 27 divided by, and let's see, on the side here, that's 1/3 times 1/3 is 1/3 squared, which is 1/9. So divided by 1/9. Now I have to remember how to divide by a fraction. Well, that is keep, change, flip. So that's 27 times 9. Coming over to the side here, 243. 243 tiles are needed. All right, now Mr. Grant is deciding on a different sized tile. So now the side lengths are 3/4 of a foot. And we want to know how many of these tiles he'll need to be. Same equation that you're going to substitute in for, and then you need to come up with your answer. So go ahead and give it a shot. Use the example above to help you, and we'll talk about it in class. All right, here's some straight up practice. We want to evaluate the expression t squared minus 12w divided by x. What? 3 variables? Don't panic. They tell you what they are. T is 8, w is a half, x is 3. So just change those to the numbers they told you. And remember to obey PEMDAS. Parentheses, exponents, multiply, divide, left to right, add, subtract, left to right. All right, see you next time.